Okay, now I am recording. First, we have to insert Revit families. So we have to go to plumbing. So the first one, do not use the architectural ones. You can use the architectural if you are using the architectural template. But if we are working with a mechanical template, we have to use this MEP. Equipment, I inserted this water heater. Okay, so open this water heater and we need this in our drawing. Then we need fixtures. What kind of fixtures? We have everything here: appliances, bathtubs, drinking fountains. Drinking fountains, as you can see, are always attached to a wall. Okay, so there is not a detached drinking fountain. So you need to create a wall, and then you need to insert the drinking fountain. What else? Fixtures. What do we need now? We need sinks. So let's create. So I don't recommend you be very creative for this exercise. Okay, so let's insert the easiest sink we can find, this one with cold and hot water. We can select this one. Okay, so we need sinks. Then we need urinals. Which one? I don't know. If you have a favorite urinal, you can install it. I will use this one. But this device or this fixture, we need a wall again. Okay, so we cannot insert this urinal without a wall. So let's select this one. And we need toilets, water closets. This. I think this is the one we have in the TDS center, something like that. Okay, so we can use this, the flush valve, floor mounted. Okay, let's use this. Let's use this. So now we have inserted the fixtures that we need. We have sinks, we have urinals, and we have water closets or toilets in this public restroom. I told you that at least for urinals, we need a wall. So we can just place a wall. This is an 8-inch generic. Let's make it 5. Okay, so that's it. We have walls. Look at this. I've been using the mechanical template for walls. Okay, you can create walls, but then you can edit them. Okay, if you want to assign properties to that wall, then you have to go to the architectural discipline, and then you can come back to the mechanical. But I don't. Okay, so we are not interested in modeling something. Oh, by the way, in Revit, sometimes we are out of sight because we don't see model geograph region. Okay, just to make sure. So those are the walls, and now we have to start placing the fixtures. So let's do it. Systems, fixture. So let's start with the sinks. So as you can see, if you want to change the orientation of the sink, you can insert it and rotate it, or you can click the space tab and it changes, you see, just by clicking space. space, and this is the orientation of the sink. I think we need to change the elevation, okay, because the elevation, S is 0. So what is the elevation of a sink? I think the top of the sink, it's at 3 feet, kind of. So this elevation can be 2 and 5. So let's go to the east. Okay, so that's it. This is a 0 level, and this has to be around 3 feet. Okay, so the top of the sink is like 3 feet from the level 0, from this level. Okay, so we can change the elevation before, and then we can copy this multiple. And as far as I remember, there were 4 sinks. 1, 2, 3, 4. Again, if we want to make them at the same distance, we have to go to annotate, align, and then we have to select this face and this and this and this. Okay, and now we have to click here, and now they are EQ, means that the distance is the same. So here we have for well, I made a huge restroom, so let's make it smaller. So those are the sinks, and now we have to insert the fixture, the urinals. With what do we want, a 1-inch flash valve or a 3/4? I don't know. I will use this one because I told you that I tend to save water, so let's make this 3/4. And as you can see, if you are here in the middle of nowhere, you can insert this device, this fixture, so you have to attach it to a wall. Okay, so we have 1 and 2 urinals. Again, what's the elevation? I think it's too low. So the elevation is 1.1. I think this is better. Okay, so here we have the sinks. This is the urinals, and now we need the toilets. Systems, fixture, toilet, and what do we have here? Private gallons per feet. This is the flow greater than private public. Okay, so this is a public, and this is a gallon per feet. So this is the water flow. So I will use the lowest one. So 1, 2, and 3. Okay, so in this, yeah, we have 4 sinks and 2 urinals and 3 toilets. Okay, are we done? No, we're not, but now it's quite easy. As you can see, if you click here, the sink, we have we have cold water and we have hot water, and this is the drainage. Okay, so today we are going to work with this. Next week we will work with the drainage, but now we are going to work with the cold and the hot water. So this is red, so this is hot. This is blue. This is cold. So we have to create a pipe, draw pipe, and since this is a wall, we have to go beyond the wall. So let's say here. Okay, so now we can do the same with all the things. There you go. Let's start with the cold water, and then we will move to the hot water. Okay, but, now we are working with the cold water network. Okay, so by selecting this, we have a lot of information. Here, we have the number of fixture units. It's 4 fixture units. I think in our example, the toilet was 5. Well, it depends on the toilet. But here we have 3/8, and here we have 1 each. Okay, so that's a good thing in Revit. We don't have to make that decision. So it's here. Okay, so we are using this toilet. It's a 4 fixture unit toilet with a 1-inch pipe here, and that's fine. We don't have to think about it. But now we know what fixture units are and what this 1-inch means. In our exercise, it was 3/8. This is 1 inch. Doesn't make any difference. And this is important because we will have a cavity here. Okay, so we have to go beyond this drywall, and we have to go that way. And this is okay. So we have all the information here. So the diameter of this is 1 inch. Here we have the fixture units. We have the flow, so we have all information here. Okay, and for this one, this pipe is 1/2 inch. This is the same as we did here, because for the sinks we had a 1/2 inch pipe going. Okay, and what about the fixture units? If we select that sink, it's 2.25 fixture units, and here it was 2.25, so it's the same. Okay. Um, what can we do now? Okay, now we have to think about it. Here we have our wonderful toilet. And now I told you that I recommend you the supply pipe should be from the ceiling. It's not from the floor. And since I'm the client here, so this is what we are going to do. Okay, so we are going to supply water through the ceiling, not through the floor. So for this pipe, now we need to go up. Okay, so we can sometimes, if we decide to work with the 3D, with the front view of a 3D view, here, this is the pipe. Okay, this is horizontal, so this is the sink itself, but we have created the cold water pipe, so this is it. Can we draw pipe and going up? No, we can't. Okay, sometimes, yeah, we can, because we can change the elevation here, but it works better through elevations. Okay, so this is level 15, this is level 30. So where does this pipe come from? So here we can draw a pipe, and here it can go up. Okay, so imagine that we have a false ceiling somewhere here, and the water will come from the ceiling. So we have to go up. And now on this 3D, we can do the same here, or I think it's easier because here we have created the horizontal pipe and the vertical pipe. Okay, so let's delete all those. And if we know what we are doing, I think it's easier if we do what we want to do with one of the sinks, and then we copy all these. So now all these sinks will have the vertical pipe. And the good thing here is that working with the front, with the 3D front view, we can work with horizontal elements. So from this one, I just need to select, right click here, draw pipe, and I can go all the way. No, I don't like it. So do not use the north elevation. Okay, so here we have the north elevation, and we have to go draw pipe. So we draw a horizontal pipe, and this is the beautiful thing in Revit. I love Revit because here we have automatically we have a T, so we don't have to do anything. Okay, it's perfect. So now we have this horizontal pipe, and then from this horizontal branch we go down to supply cold water to this the faucet, to this faucet. And now we would have to do the same with the toilets and the urinals. So let's work with the same strategy. Let's work with a vertical pipe, and then we will copy it. Okay, so we are working with a toilet and a urinal. So let's work with a vertical pipe, and then we will copy that vertical pipe. So this is the east elevation. This is the horizontal toilet pipe, and then we can go up. Draw pipe. What is the limit? Since we have this reference here, so we have to connect this to well, usually you can highlight this, but this is a very small. Okay, let's do this, and then we will connect both. So this is a vertical pipe, and now on level 0, we can copy and paste 1, 2, and 3. And then from the urinal is different because if you look at, okay, if you look at it, the water supply, it's here, it's above. So what do we have to do? First, we have to go up, then we have to go horizontally, and then we are here. Okay, so let's do it. So first go up, then go this way. And what have I done? Yes, I have done this. Be careful because this is a common mistake. Okay, Revit is great because it automatically connects things, but here it has connected the urinal to the toilet. That would be terrible. Okay, thank God we have plumbers. So when architects make mistakes like this, there's always a plumber that say, okay, they are crazy. But be careful because if we are working with the elevations and then we go horizontally, it automatically connects this, and we don't want to do that, so be careful. So make sure that it's not connected. Okay. But we want to, okay, on this level 0, we want this to be aligned to this pipe. Okay, so let's do this now. So now we can select the vertical pipe, Now we can draw this horizontal one, and we can go all the way here. Okay, we have 2 urinals, so let's copy this one, 1 and 2. And now on the 3D model, we do want to connect this one to this pipe. So let's do it in plan. Okay, so in plan, if we do this, now it's connected with a perfect T and a vertical pipe. Beautiful. Okay, so Revit is it's so good that sometimes it does things that you don't want to do. Okay, because it automatically connects everything. So sometimes we have to look at the 3D to say, okay, is this what we want? Yes, this is what we want. So that will be perfect. Okay, and now we only have to connect the two branches because we have this branch and then we have this one. So on level 0, yeah, we have to connect this. But if you remember, we didn't have the same height here. Um, so we can either does the align tool work? I don't know. Okay, so from this point can, no, from this one, better. We can draw this pipe. There you go. Okay, Revit is so good that even this is not what we want because this pipe and this pipe are at the different levels. But piping it's quite easy. So if we don't want to think too much, you just do this, and Revit solves the issue. Okay, so you see, levels are different, but they are connected now. If we want to be accurate, we have to make sure that both pipes are at the same level. But because the fewer the fittings, those fittings are quite expensive, by the way. Okay, so if we are designing a very bad layout with a lot of fittings, maybe one of these fittings is like $3 or $4. Yeah, well, $3 or $4 is nothing bad. But if you multiply this by thousands of fittings, you are wasting a lot of money. So we have to reduce the amount of fittings. And here we don't need this distance. Anyway, I'm not going to fix it, but I would appreciate if when you are doing this, you reduce the unnecessary fittings and the unnecessary piping. So this is not necessary, this pipe here, and this elbow, it's not necessary because we have a T here. So if these two pipes were at the same level, we wouldn't need this pipe and this elbow. But it is correct because Revit has fixed it. And are we done? Well, now you know what it takes. Now you know that according to your calculations, this pipe connecting four toilets. No, what was? Okay, yeah. So this one connecting the toilets, it has to be one quarter, and this one should be one half. We can do it in Revit. Okay, if we know that this one should be one quarter, so this diameter is 1, we can click here and we can make it one quarter, and this is one quarter as well, and this one is one half. There you go. And what about this? I think this should be oh, this is 1. And this is 1 as well. and this. Okay. So this is what Revit doesn't do automatically. So it doesn't change the diameters of these. So that's why it's good drawing the layout by hand first, doing this rough calculation first, and then we will end up having one half. If you have done this 3 or 4 times, you know that if you connect toilets and urinals, this has to be one quarter, and then when you connect everything, it has to be one half. Okay, so if you calculate these 2 or 3 times, that would be enough. Okay, so we are done here. This is what we did, and now we have done it with Revit. Perfect. But I want to go a little farther because, yeah, because I want to go. And what happens? This is a okay. If we look at this, there are 2 restrooms here, and we know that sometimes there are issues with one of the restrooms, and it's closed because there are people fixing jams or whatever it happens here. We know that. What happens if we have 2 different restrooms? Then we need to cut off this circuit here and there. Okay, so we would need a cut-off valve. So we are going to insert valves as well. This is what is represented here. Okay, before entering if there's a problem here and we need to cut off the water of this restroom, okay, we cut off the cold and the hot water, and it's perfect. The building is working well, and only this restroom is canceled or is not working. So now we need to insert these 2 valves. So to do this, we have to insert, allow the family. And where are these valves? They are not in the plumbing. They are in the pipe folder, pipe. Okay, so here we have fittings. We have these IWWA valves. Let's use this one, this valve. And well, we are not plumbers, but if we were, we have a universe of valves and fittings and things here. The plumber I was working with, he loved the ball valves, but here we have only from 2 to 6 inches. This is too much. So we can use balancing valves. And here in balancing valves, we have circuit setter. So that means, and this is from 1/2 to 2 inches. And this is from 2.5 to 4 inches. Okay, so for these kind of buildings, we can use this one, this circuit setter for from 1/2 inch to 2 inches. So let's open this. And now we can insert that. I have to go to the top view. Okay, so before entering this restroom, we need a valve to close this circuit if it's necessary. Let's insert this. Here you see that we have pipe accessories. This is a valve, this picture. So we click here and we have this circuit setter, 1/2 inch. I wouldn't do that because this is 1/2. So we do have a 1/2 valve here, and then we can insert it here. There you go. Okay, so now if there's an issue with this restroom, by locking this valve, we can cancel all these pipes. Perfect. Is that no? We can do more because we can even go to the building supply. I told you that the building supply usually is well, we have a box here underground out of the building, or it might be in a mechanical room. I don't know. But imagine that if it is the limit of the building, we go out, okay? And here we have out of the building, we have something. So let's see. Okay, so first we need to go down because usually that box it's underground. Okay, so we can go down here, draw pipe. Let's go below level 0, it's underground. And then let's go this way. Okay, so we are out of the building now, underground. There should be within the building or in the lobby or somewhere, we need a shaft to go up. And then through the ceiling, we distribute the rest of the water. And here we need the main water pump because we receive a pressure here, but just in case we need a water pump here. If the pressure of the municipality drops, if there's an issue, if there's a pressure loss or there's a leak or whatever, here we have our pumping system so that we can pipe the water with the right pressure to the last fixture that would be on the second floor. Okay, so let's do it. But we have to insert another device. And pumps, insert load family. Pumps are not here, are not in the pipe folder. They are not in the plumbing folder. They are in the mechanical folder. Okay, so this is a little confusing. So we have to go to the mechanical folder, and then we need to go to water side components. And here we have pumps, we have water pumps. What pumps? Again, if we were plumbers, we would find here everything we need. We can select the inline pump, which is the easiest one. Okay, so let's select this inline. And where is it now? It's not in plumbing, it's not a plumbing fixture, it's a mechanical equipment, this inline pump, you see? Well, we can work with level 0. And remember that, okay, so we have to make sure that we align the pump to this, okay? So we click here. Okay, I did something wrong because I wanted to insert this in the horizontal pipe. Oh, I see. We have to work with the view range and make it unlimited. Okay, now I see this. Okay, and now I can insert mechanical equipment, the inline pump, make it here. There you go. Okay, so now this pump is underground, probably outside the building. We have a metallic cap. We open that cap and we find there the main pump of the building. If it's not here, it will be in the mechanical room. The mechanical room of this building, it's on the roof. It's underneath the roof. So I'm sure that we have something here to pump the water to the roof, and then from the roof we move the water to every single fixture. Okay, but we're doing this, so this is feasible. So we can have something outside the building. This is the main pump, and then we have to pump the water to all these elements. Is this everything? No, we can make it even better, because what happens if this pump stops working? And it will happen after 50,000 hours, but eventually this pump will stop working. And then that will be a mess, because that pump affects the whole building. Okay, if we have an issue with this pump, the whole building is without water. We can do that, we can afford that if it's only for a couple of minutes. what it takes to remove this pump and to place another one. So if we do this during the night, nothing noticed. But we need two valves. Okay, so we have to insert, and this is not the kind of valve. This is to separate different circuits. So when we are getting to a room, to a restroom or a kitchen or whatever, we can have one of those. But if we're working with pumps, we need another kind of what is it? Insert load family, and now we have to insert another valve. So this is in the pipe folder, valves, and I inserted the balancing valve, but now I want to insert a butterfly valve, this one. Okay, and now we go to level 0 again, and before and after the pump, I have to insert this butterfly valve system, this pipe accessory, and make sure that you align this here and here. Perfect. Okay, so if there is an issue with this pump, I close this valve, this one, and now if I remove the valve, the water doesn't escape because it's in this pipe. Okay, so we have a valve here so that I can remove the pump. You remember that I told you that sometimes we can have two pumps so that the building is not without operating, not even a minute. Let's do it. Okay, we have this, and now we can make it shorter, and we can make this shorter. Well, this looks like a professional thing now. Okay, so we have this bypass. So if this pump is not working for any reason, then we can work with this one. And we close this. Usually this should be closed, and this should be closed, and this is open. When there's a problem here, this is closed, and these ones are open. And now we can replace this pump without stopping the operation of the building. Okay, so this is high level. Okay, so we are working with Revit. We can do this easily. We can have these pumps here, and this is all we need. Well, this is all we need. If for a simple restroom like this is all we need. If it's more complicated, we would need more things. Okay, but it's quite easy, and I think it's by looking at it, we understand perfectly what we are doing. Okay, are we done? The cold water, it's done, but am I happy with this? Not yet, because we know that there are two floors. Okay, so once we are done with the first floor, working with the second floor is a piece of cake. So we can select all these, we can copy from this level to the upper level. And there you go. Do we have to connect these to this? Yes, we have to. This is the valve. So we can draw another pipe here. And now the problem is that we have an elbow here, and this should be a T. So we can either replace this elbow or we can delete it. And then we work with elevations, with the east elevation. Yep, I can extend this up to this point, and then I can extend this here, and we have the elbow. And here, if we extend this pipe horizontally, we will have a T. Perfect. Okay, this is much easier than working with ducts, because the diameters are so small that immediately you can connect elbows, T's if you're working with ducts, you know that if you have an elbow, you need a distance, and if the distance is too short, you can have this elbow. With pipes, everything is easier. Okay, so imagine that you have a third floor, so you only have to copy this, and so that's the right way to address issues or these kind of issues with Revit. Finish one, and then you can repeat them. Don't do it all the toilets at the same time and then all the sinks. No, just work with restrooms. And usually in buildings, we repeat the same restroom in different floors. And this is what we have to do. So first we finalize one of them, and then we can copy and repeat them. I'm not happy yet. I think we can make it better. So let's do it. I'm very, yeah, I think we can make it even better, because we are done with the cold water supply, and if you click here, this is the domestic cold water, okay, but we haven't done anything with the hot water. Where do we have hot water here? Do we have hot water in the urinals? I don't think so. Do we have hot water in the toilets? We don't have hot water here, but we do have hot water with the sink. Okay, probably I should have done it before instead of doing it now, because then I can copy this to the second floor. Okay, I'm going to do the hot water only for for the first floor. Okay, and then you can do the rest. You can do the second. So for the hot water, it's easier because, well, it's much easier because we don't have any, we have fewer fixtures. We only have the sinks. We don't have all these. And we have fewer water fixture units, so it's easier. Let's do it. The only thing we have to keep in mind is that we don't have to, we can't have intersections between the hot water and cold water. So if we have a pipe of cold water here and another pipe of hot water there can't be an intersection. So the levels have to be different. So this is the hot water and this is the cold water, and we should avoid intersections between hot water and cold water. That's a huge mistake. But we can, well, that's easy because it's not difficult. I mean, it's very simple, so we can do it. But where does the hot water come from? It doesn't come from here. So this is the city, the municipality supply, and the municipality supplies cold water. It doesn't supply hot water that I know of. So we need to lead our hot water. First, we need a heater, we need a water heater, and then from the water heater, we have to go to the sinks. Okay. If you remember, we inserted, was it a plumbing fixture? No. Was it a mechanical equipment? Yep. So here we have the water heater. For 40 gallons, 50 gallons, 75 gallons, 100 gallons. Okay, let's select 75. And this water heater is in the mechanical room. And we don't know where the mechanical room is, but let's place it here. Okay. And now we have to connect these to this. How can we do it? Okay, first analyze the water heater. Okay, so for the water heater, what is this? This is a drainage, because sometimes we will have to empty the heater. So we have to connect this to the drainage system. This symbol here is electricity. because this runs on electricity, this water heater. Actually, this is what we have in the TDS center. We don't have a gas water heater. Everything runs on electricity. So this is running on electricity. And what is this? We have this out. I don't know what this is, but those are water pipes. This is for what you call it. Well, if you want to relieve the pressure, you need to open this to the air. So this is an air pipe or an air duct. We're not going to use this. We're just focusing on the cold water because we need to supply cold water, and then we have the heater here, and then we need to go out with hot water. Okay, so we need this inlet of cold water, and then we have this outlet of hot water, and then we go to the sink from this outlet. So we have to connect this supply, this cold water supply, to the water tank, and then from the water tank we have to connect this pipe to the sinks. Okay, let's do it. Well, let's do it. Okay, there you go. So from this vertical pipe, we should go to this inlet. Okay, so we have to connect these both. So let's throw pipe here. Let's go up. And now we can use the Revit features. We can just connect this and see what happens. And probably it is well connected. Yes, it is. Okay, so we have this water supply. Part of this water supply is going to the water heater. And then from the water heater, we have to supply hot water to the sinks. So now on the north elevation, we have to supply hot water. You have to be careful with this. We need a different level. Okay, so if this is the level of the sink, the cold water, we have to make sure that there is no intersection here. Let's do this. And we have to be careful because we don't want to connect the hot and cold water. Okay, so this is the cold water supply, and this is the hot water. So we have to make sure that we don't connect both pipes here. So we can go like this, and then we can go like that. Since we are working at different levels, this is not an intersection. Okay, so this is important because we are not intersecting these two pipes. So this is the cold water and this is the hot water. And then we have to connect this to the sink. If this is the hot water from the sink, we can draw pipe. And if we extend this, okay, Revit is wonderful. I love Revit because we have an elbow, two elbows, a vertical pipe. Okay, so Revit does everything. And here we only have to connect all these here. And here. And there you go. Okay, so now everything is connected. There is no intersection. And if we want to know that everything is correct, now we have to check this pipe, for example. This is domestic hot water. It should be domestic hot water because it goes out from the water heater. what is the total, the fixture units? It's 9. Does it have to be 9? Well, because it's connecting 2.25, so 2.25 times 4, it's 9. Yeah. So if everything is well connected, the total water fixture units should be 9. What is the total water fixture unit in this pipe? It's the fixture units that we have from the 6 toilets, 4 urinals, 8 sinks. So it's 98 fixture units. If we want to select this, because now this is 1/2. Is it enough? So let's find out in this table how many fixture units do we have. The maximum developed length was this one. If we have more than 90 fixture units, we take this 125, so this should be 1/3. It makes sense. Okay, so this final pipe, because here we are connecting, this can be 1/2, because this is serving only the second floor restroom. This is 1/2 because this is the first floor restroom. But here we are connecting both. Here this should be 1. We don't have 1/3. Okay, 2 inches. And then all these should be 2 inches because it comes from. Okay, so you know what I mean. So all these should be 2 inches. But it's quite easy. If we can design one of the toilets, with one of the toilets, we are designing all these pipes. And then when we place together all these pipes, then we have to go back to the table and we only have to check if it's 1/2, if it's 1/3, or if it's 2 inches. If we don't have 1/3, we can make it 2, doesn't matter. But we can't go down. Okay, so if we are connecting 1/2 to 1/2, the result can't be 1. It has to be either 1/3 or 2. That's the only thing we have to control. And there's another way to control this by the velocity. You see that those are feet per second, the velocity. So there's a table in which we can control the recommended velocities of pipes. So if this velocity is too high, what can we do? Okay, so this is what we have done. Look at this. This is 10.54. If this velocity is too high, this pipe is 1/2. If we want to make this velocity lower, we can select here 2. And now the velocity is 6. I think we are done here.